Welcome back, focused learners. Today, we are diving into a really massive, high-stakes shift happening right now in the AI space. We're talking about moving away from those simple static language models that just spit out answers to our questions and stepping into the era of complex, autonomous digital agents. It's totally changing how we interact with, and honestly, how we measure artificial intelligence.
Because, look, here's the reality. AI has moved way beyond just chatbots. We aren't just pinging a system back and forth anymore. We're literally unleashing autonomous digital interns. These are systems built to take on long-term projects, make game-time decisions, and even fix their own mistakes without us hovering over their shoulders.
Okay, let's dive into this, because that level of autonomy introduces a pretty massive problem. How in the world do you grade an AI that acts totally on its own? Since these agents are running unsupervised in the background, a failure we don't catch could be disastrous, especially in high-stakes fields like medicine or coding. We absolutely need entirely new, robust evaluation frameworks to figure out what they're actually up to.
So to tackle this, we're going to use an anatomy and autopsy framework. First, from chatbots to agents. 2, anatomy of an agent. 3, the evaluation challenge. 4, real-world agent benchmarks. And finally, 5, your evaluation roadmap.
All right, let's jump right into Section 1, from chatbots to agents, the paradigm shift in AI capabilities.
Now, while standard large language models, or LLMs, are still the underlying brains of all these systems, the line between a simple prompt responder and a true autonomous agent has completely shifted. Think about the intern analogy. A conventional LLM, that's an intern taking a static multiple-choice test. It's narrow, prompt in, output out, one and done. An AI agent, on the other hand, is an intern managing a complex, multi-day project. It runs an autonomous workflow, reaches out to external tools to interact with its environment, thinks over long-time horizons, and most importantly, dynamically recovers when it messes up along the way.
Which brings us to Section 2, Anatomy of an Agent, breaking down the digital worker.
So there are 3 main anatomical parts to any agent. First up is the underlying LLM, which is essentially the reasoning brain. Second, you have the external tools, and this is a massive deal. When you teach an AI to, say, hit the OpenTable API or use a command line interface, you are fundamentally unlocking its ability to interact with the real world. Finally, the third piece, the instructions. These are the domain guidelines, explicit rules, and edge cases that keep the agent from going totally off the rails.
And these components really come to life through what's called the Agentic Loop, specifically looking at the React framework. React simply stands for reasoning and action. It's basically this iterative process where the agent constantly observes its environment, thinks about the best next step, takes action, and just repeats that loop until the job is completely done. It beautifully captures that vital, symbiotic relationship between thinking and acting that pushes the whole system forward.
But sometimes a single agent just gets totally overwhelmed when its tool set gets too bloated. That's when we start breaking tasks down into specialized multi-agent systems. You've got the manager setup, where a central boss agent delegates tasks to sub-agents, which is perfect for pulling together really complex stuff like language translation. Then there's the decentralized setup, where agents act more like peers, naturally passing the baton. That setup is incredibly useful for things like triaging IT support tickets.
Moving on to Section 3, the evaluation challenge, testing autonomous systems.
So, how do we actually grade an intern that's doing its own homework over several days? Well, you have to build an evaluation harness. Think of this as your end-to-end testing infrastructure. Because an agent operates autonomously over time, you can't just grade the final essay and call it a day. You've got to monitor the entire long-horizon workflow. This harness manages realistic task inputs, records the agent's multi-step transcripts, and applies graders to verify the final outcome in the actual environment.
Now, the trickiest part here is choosing your graders. Human evaluation is obviously the gold standard, but man, it's slow and expensive. Code-based graders, like running simple Python checks, are super fast and perfectly reproducible, but they're very rigid. Then you have model-based graders, where you literally use another LLM as a judge. That gives you human-like flexibility, but it brings in all those well-known AI biases. Because no single method is going to catch every single autonomous error, you absolutely have to layer them into what's basically a Swiss cheese strategy to cover all your bases.
All right, Section 4, real-world agent benchmarks, putting agents to the test.
A really great example of elite researchers building robust harnesses in practice is the Tau Bench framework. It totally exposes the brutal reality of evaluating agents today.
In the past, we'd use this very forgiving metric called pass at k. Basically, did the model succeed at least once if we gave it k independent attempts? But for autonomous agents, we need the super strict pass k metric. Can the model succeed consistently on all k attempts? I mean, if you tell an agent to book a flight 4 times, you need it to get it right 4 times, not just once.
And when you apply that strict pass-k metric, the results are honestly pretty shocking. Even a highly advanced reasoning model like O4 Mini only hits a 26% success rate on the Taubench telecom domain when asked to do it 4 times in a row. Let that sink in. That number visually proves a really hard truth. Despite being incredibly smart, modern agents still severely struggle with consistent, reliable execution.
To push boundaries even further, researchers created Terminal Bench. As the creators put it, benchmarks must evolve to capture the diversity and difficulty of frontier tasks in realistic environments. One such environment is the terminal. So Terminal Bench takes that philosophy and tests agents on 89 outcome-driven software engineering tasks inside real Docker environments. And get this, even top-tier models like GPT 5.2 are only hitting a 62.9% resolution rate there. It's a seriously tough test.
Finally, Section 5, your evaluation roadmap, a practical guide to building harnesses.
So how do we take all this theory and actually use it? Well, we can distill everything down into a super clean 5-step process for testing your own autonomous systems. First, you've got to define crystal clear success criteria. Second, start small. Just grab about 10 to 20 realistic manual tasks. Third, add your ground truth reference solutions so you know exactly what correct looks like. Fourth, configure those fast deterministic code-based graders before you start paying for expensive AI judges. And finally, build out your controlled, reproducible evaluation harness. From there, it's all about iterating, verifying with real humans, and improving the system as your agent inevitably makes mistakes and learns.
We've covered a ton today about the dramatic shift to autonomous systems and how to actually test them. But I want to leave you with one final, slightly provocative thought based on this roadmap. As we start relying more and more on LLMs acting as judges to grade other autonomous AIs inside these harnesses, as these agents become increasingly human-like, who exactly is going to evaluate the evaluators? Definitely something to think about. Thanks for joining me on this explainer, and keep learning.